So
I think it's recording, so
that's now. Okay, so what I offer to talk about Uparse because it's kind of the interesting thing. I've actually been programming in Rust and doing some other stuff this week, and kind of wandered off from Rebel, but coming back to it here, the thing that I noticed, and I mentioned this how we were doing seeing the parse of binary, especially in zip and in when Shizhen and I were doing the end capping. I always thought like, hey, wouldn't it be great to have some these parse rules that would be processing binary data, but it turns out that it was kind of bad. And I mentioned some of the things that made it bad, and what that was is you can see it if let's look at here's some code that I changed out of the I think it's bigger here. Code that I changed out of the unzip, you'd see these patterns where the binary would have you do something like copy out a couple of bytes. This is copy name length into a variable with two bytes. So it puts that in the variable. Now you've got 2 bytes in a variable, but you're always wanting to do something with it, because a binary is never what you want. With a string in your parsing, sometimes little fragments of strings are exactly what you want, more often than not. But with binary, it's almost never what you want. With binary, you're always trying to turn it into some kind of integer or turn it into, part of it into a string. And so you'd always have these 2-step processes where you would have the capture, and then the capture would have to do some kind of conversion in parentheses after it. And this would happen all over the place. And you couldn't abstract it. And there's really no way to build some higher level tool that stayed inside of parse. You could write something that would generate parse rules, and then that would generate the copy and the group, and then run the parse rule. You could do that, and actually Shizhen did that. He made the end capping use a higher level dialect in order to generate the rules. But that seems kind of antagonistic, and starts making you wonder, why is it that parse is sort of stuck for every set and every capture being stuck into the same series type as your input. And when I was looking at Haskell, for example, and parser combinators, they aren't stuck doing that. They actually, for every little piece of the parser, they can build a new part of it. It's just like a function. And this is and they say Combinator, they're talking about taking parsers and combining them together to build other parsers. And this is just a really simple example of an IP address parser. So when you look at it, it's pretty clear. They're able to, here's their set, which says, hey, we're going to make a D1, and we're going to feed that from the rule, the existing parser, for decimal. And then they're going to match a character using the character parser that takes an argument, the dot, and they do another assignment. Their D2 comes from parsing a decimal, and then another dot, decimal, dot, decimal. Then they look for a new line, in this case, and then they return from this parser that took a stream of input an IP address structure out of those 4 decimal numbers. And the thing is that now they have parse IP, and they can use this like we would reuse a rule, but the rule can actually generate another value in another one of these composite parsers. So their rules are actually functions that operate on this implicit input. You know, you notice how the rule for matching a character, it's a function that takes what character to match, but it's not having to take the input. The input is an implicit parameter to the parser because it's in that domain, in the parsing monad, as they call it, which is just a fancy way of getting those implicit parameters and to keep everything homogeneous in this domain of being parser like. And so I was wondering, you know, why can't we do that? You know, why doesn't why don't parse rules have return values? And so Uparse was kind of jumping in to study that question. So I just kind of sat down and wrote it in user mode because I thought that, you know, it would be a good test to see if the successor to parse could be sort of architected and designed in user mode. So we think like a user who's trying to design a dialect, which is very parallel to the Haskell concept of parser combinators. It's not a special language feature. It really is just using the features of Haskell, and because of the existence of these monadic properties of the language, they can have those implicit parameters, you know, making functions that are picking up parameters out of the sort of universe that they're in. But we're obviously doing something pretty different. We'll borrow, you know, it'd be good to borrow things when they make sense. But I wanted to start making the rules up out of combinators. So let's just look at we'll look at a familiar combinator. Let's look at, let's say, the sum combinator. You know, match something at least one time. So if you look at the definition of the sum combinator, it takes a parameter that's an action, which is a parser. So the idea of this is that it's just a rule, but it's a rule that's been converted into a function that you can call. So the job of the Uparse engine is to take those blocks and arguments and translate them into a function that can be called to operate on input. So what we do here is you see it calling the parser on the input. And you say, well, where does the input come from? Well, the input is an implicit parameter. This combinator, notice I define this with combinator. I don't define it with function. But combinator is just abstracting function and adding some implicit common properties to it. So one of those is the implicit input. Every combinator has an input. So that just is a given here. So the first thing we do is we call, if we're going to run a sum combinator, is we run the parser on the input. It returns us a result. This is a multi-return. So it has a return value, which is what the combinator synthesizes. You know, kind of like how the IP address parser returned a structure that's an IP address. The decimal parser returned a decimal number in Haskell. Here we're saying that every parse rule synthesizes a value. And that's the first return result. And the second is the new position after the match. Now, what if it doesn't match? Well, if it doesn't match, then the primary return result will be null. Okay? So the first thing we do when we're processing a parse input like sum is we check for a match, and if we don't get one, if we don't get at least one, we return null. After we've gotten past the first one, we know we're going to return success, because sum will always return success if it matched at least once. So then, in a little cycle, we keep running the parser on the input and get a new position. We don't actually, we save the old position, because if we fail the match, we're going to want to use the old position as how far we got. And then we have to set the remainder of the input, the second return result from sum, to that. And then we return the last result that successfully ran through the parser. And that's it. That is how you write a parse combinator. It's not particularly challenging. It's not rocket science. And so you can see down here, you can get more imaginative. I made the tally rule. And the tally rule is just a way of counting how many times a rule matches, and it synthesizes an integer. And how do we do that? Well, we have a local variable in the combinator here that's count. We start at 0. We run in a loop. If we ever see the parser failing, then we return the count that we had so far. Otherwise, we increment the count and we move the input along. And it, these are not hard to write. So when we come in here, I can say uparse AAA, tally A, right? Oh, I forgot. We're in the browser doesn't have uparse, so we have to run it. Oh, I don't have. It's been a week and I haven't done this, so I forgot what you have to do. Uparse.
Right. Yes.
Okay.
Sounds familiar.
So
I mean, it's well documented in your notes, so I've been stung by that before. But yeah.
So there we uparsed the AAA. We assigned the count, the result of tally of A, right? And if I say count tally of A, count will be 2, right? Because it all the work, you notice that tally isn't concerning itself with the nature of the rule that's being given, right? It just took a function that processed input and returned a value. So the whole, tally works equally well if you put things in a block or if you don't, right? So that's pretty easy to understand, right? I feel like it should be.
Yeah, I personally, my experience with cycle, or it used to be called forever, right? I mean, is in my mind is it's something that's going to be long running. It's like a service that continues to run, but this is just basically execute until a null, right? So
yeah, well, forever, if you have something that's really forever and it never exits, then yeah, I mean, I like cycle as a name better than forever because it doesn't imply that it'll never quit. So yeah, if we skip over a few of these here, so
when you're parsing when your rule is returning multiple values, then you actually get a block return, then you can then process, or
when you're returning multiple values,
because I mean there is just you just doing a count, but if you wanted to return all those values like your finding all the IP addresses in a document, you would get a block of all the IP addresses.
Yeah, yeah. You can return any value. Like if you look at collect, right? Collect returns a block, and collect is just a this is all trying to build on what I said to Chris when he was asking for collect. I was like, every time someone gets an idea doesn't mean they should have to crack open C source code, right? You should be. It's okay to consider some of these being written as native code, so they're not running evaluator cycles for running if and running the parser and running the call, right? If this stuff is hardened native C, but it implements the same interface, it's a lot faster. So you could be using a mixture of natives and user mode implemented functions to do your matching. Right now, Uparse is all user functions, so it's extremely and painfully slow. But that's just because I'm still working it out. I mean, but the moment I want to, we can write these as native code, right?
But of course, the JavaScript engine increases in speed. This will increase, won't it?
Well, we run WebAssembly, not JavaScript. So JavaScript speeding up won't make us any faster. WebAssembly is fast, and computers are getting faster. And I'm really not that concerned about it for the kinds of things that we're doing. What I am concerned about are the sort of little aesthetic points here. And I think that, when we do it right, we're not just competitive with Haskell and stuff. We're more accessible, right? Like you can do more interesting things. We're never going to perform like that, and we're never going to have the correctness. It's just not the domain we're looking at. We're looking at a different kind of problem and a different kind of game. But here's an interesting one. This is between. And between was something that it's a solution to a problem that I was always kind of bothered by, which is, why do we not have a better way to to eliminate that to something, and then you have to skip it after you've matched it, right?
That is annoying. That's annoying.
Familiar example is that you got like AAA, and you want to say, okay, I got a left, and then I want to, we're gonna do this in new notation.
With tags all the time. I'm always doing XML or any kind of markup, and they're always skipping all over the place.
Then you have to do like X to that skip, right? And that sucks. But you could all, and if it's, sometimes you do like that, but you end up repeating yourself. And I was trying to figure out a way to fool, I was saying like, well, what if it was like, I'm trying to remember what I was suggesting. I was saying like, then something, or I had some kind of rule where it was like, okay, the rule has a left side and a right side, and there'd be an operator that would sort of convey that. And I didn't have the language for saying what I actually wanted. So, but what that is here is between.
So it's like copy and skip or something like this.
So that's nice. And you also have, and the question of, well, how do I formulate that in a one-sided way? Well, like, let's say you wanted to do, let's say that you did something like this. Well, when you get the here can match without moving, right? So even if you want to do basically like a one-sided match, like let's say it was something like this, you can do that. So between serves both purposes. It's trying to come up with that this between here and something is the operator I was trying to make before and then wire it up together, but it doesn't make any sense. Between is much better, right?
Yeah.
And
although I think the more common use case for that, at least for people like me, is that we're trying to match tags, and various things can come, so we're not using between just for a character, right? It's for a rule. So you want like a, right. I think you get it, but yeah.
So you want the data between two matching tags.
So for example, an HTML tag can have, let's say, an anchor tag. It can have all kinds of stuff in it, and you just don't care about the stuff that's in the tag. You just need to get through the tag in order to, or maybe you need to look at what's inside the tag and say, yes, this is I want to grab what's the element in between the opening and closing tags. And then in XML, you want to find those same nodes, or you need to skip over things that are simply closed tags because they're saying that there's no node at all, right? So you can have empty tags, and you can also have closed node. Anyway, I don't want to divert us.
Look forward to seeing applications of it. But the point I want to make today here is just to kind of show that between is not really complicated, right? It's slow in this implementation, but so the first thing it does is it tries to match left rule. And if the left rule doesn't match, it says forget it. So it remembers the input position here, but then it saves a new position that's the start. So the start is the end. It's the return where this left parser matched. And you notice here that between takes two arguments, two actions. And that tells the parse engine, Uparse, that it wants to have two rules fulfilled into functions that it can call. And again, between it doesn't have to worry about whether or not the left rule was in a block, or how it was expressed, or whether it was generated by code with a get group. So once we've matched the left and found where we want to start the capture, we then go in a loop and we just keep stepping forward one series unit at a time and trying to run the right parser at that position. And if we ever do run the right parser at the position on the limit that we were working on, we return the copy from start to the position before we matched, right? Because we don't want the position after we matched. We want the position before we matched. Because when this thing matches, that's like matching the right tag. And then it's going to put us in the position, this remainder is going to be the position after the tag. But what we want is the position that we gave it when it did match the tag, right? We want that input, that right parser, not the output position for the right parser. Does that make sense?
So so that means that when it's finished, you're going to end up at the beginning of the right tag?
Well, no, we're the remainder. See, this is setting the remainder to the output, but we're not using the remainder that we're returning as the limit of the copy. So this is the input position. This is the output position. And when we return the actual value that we're copying out of the input, the stuff in between, we use the starting position, which was the end of the left input, so the output of that parse, and then the input of the right parse, right? So we want the output position of the left parser as the start, and we want the input position of the right parser that succeeded as the end, but then the output is the remainder. So it's going to be a little tricky because, again, remember, every parser has two return values. One is the synthesized product. I was just sort of scrolling through here to show you the combinators. And so, yeah, showing you between, to, and through. Something you'll notice, and this is an interesting point, when I say that there are two things that come out of a combinator. One is the new position, and the other, the main return value, is the synthesized product of the rule. But and you see all this code where it's acting and saying like, hey, if the synthesized product is null, then that means that the parse signals that the parse failed. And you might ask, well, what if you want to synthesize a null, right? So, like if I say uparse x or uparse AAA, and x is opt BBB, sum A, what would you expect A to be after that? You want it to be null. So if null is a signal that the parse didn't succeed, how can a combinator return null? Well, as a general concept that I was sort of messing with is the idea that the return from the parse rule is actually quoted. So if you always quote the result. So for instance, getting the current position here, it just returns the input, but it returns it quoted, because values are always quoted to make it so that the return of null can be done. So that's sort of it's kind of a weird issue where I've been thinking a lot about what it means for a function to return empty. That's another thing, which is how does a combinator indicate that it's invisible? Inside the system, there's all this magic to make invisible functions work, right? But we can't take advantage of that because the uparse engine is all in user mode. So how does the user mode parser combinator indicate invisibility? Well, it uses an empty block. And the interesting thing about doing it this way is it's kind of made me think about how the internal protocol might do something very similar. So that if you're writing the kind of function that can differentiate between null and null2, you use a return that's basically quoted. And if you want to return something invisible, you use a return that's basically quoted that understands that an empty block would be nothing, and stuff inside the block would be a macro. And that's all kind of deep implementation stuff that's being inspired by trying to do this stuff in user mode. So I don't know. I guess I'll ask you guys: Does this seem scary? Does writing a combinator seem like something you could never do, or does it seem like something where you might go like, "Hey, I could do that"?
To me, it seemed a little foreign. It's kind of like until you realize the pattern, like there's a pattern to building these,
I think it looks.
As I was saying about.
I think it's something that we could do. Yeah, it looks very interesting.
So if you look at this commit where I changed unzip to use uparse, which I was talking about those sort of gnarly patterns. The pattern where you always had to copy out into your variable from the series, and you could never synthesize anything else. And then you do the you'd run some code to transform it. But here in the new formulation, it's probably easier if I just show the file. For unzip, so here, this is actually taking advantage of not writing a combinator, but making a rule that's able to evaluate to its result, right? So if I want to get a uint16, so a 16-bit unsigned integer, I can do that same two-step process where I capture 2 bytes out of the series and then debin it, so turn it from little endian unsigned 2-byte format. But then this whole block evaluates to that value. So the return result of a block is its result, whatever drops out. So that gives us the very obvious looking way and of saying like, hey, set this field length, which is going to come out as an integer, to the result of that rule. Which, when you compare it to that Haskell thing I was pulling out, it compares more favorably, right? Because they were just saying like, here's, D1 gets decimal, and decimal is their combinator rule. So we have something that's a little bit different, just in terms of the style of how it works. But it's interesting. So that's kind of the most of what I want to say about Uparse is that you can do it. It is showing promise. It is slow. There are a couple of weird issues that I've talked about on the forum about how, when do we have, because every rule is synthesizing a result, we don't want to be too careless about making big, fat, slow results out of common rules, right? If every time you said sum A, you got all the A's that you matched, even if you didn't want them, that's producing a lot of material. So that's why you see this across, right? Like, I basically didn't want to let a rule produce information unless you ask it to, unless it's a obvious result-bearing rule like collect. And that's true in regular code, right? If you just write, you write collect, keep 10, keep 20, then you don't do anything with it, like if you say collect, keep 10, keep 20, print next, it disappears into the void. We don't have a way to avoid generating that block. It's just not the way things work. It's interpreted. We don't have advanced notice that you're going to discard the result. So Uparse has that same situation, right? If I say Uparse AAA, collect, keep some A, then that's a bad example. BBB some B, then it threw away that collection. You have to save it into a variable or it gets discarded. Oh, that's a good example of the difference, because keep some A is different from some keep A. You see why? what I just said. We don't want sum A to be generating series results all the time. So that's why sum A just returns the A right back, which can be useful. So I'll just ask any questions? Oh, yeah. Any questions about any of that?
So I just saw that you ran these number of rules one after another. How are you progressing through your input stream? Because I mean, I know you get two return values. One is the synthesized value, and the next one is the return position, isn't it? Or the end of where your rule succeeded. Is that right?
Yeah. Well, it's the parse engine, basically the evaluator, if you would, that does the work of stepping through the blocks. In particular, there's one rule for block, like each data type. So I should show you that. So it's not just words like sum or collect or between that have combinators. Data types also have combinators. So, for instance, set word. And so what's different about data type combinators is that one of the parameters they get is the value of the combinator itself. So the set word combinator, its first argument, since it's a data type combinator, is the value of that type. And then it can take arguments like any other combinator or not. So for set word, it does take an argument. It takes a parser and it matches it and then assigns the variable the result if it matched. Text does not take any arguments. It only takes the value of the text and matches that text role. So one of those rules is block, and block is kind of the most, most complicated, most important combinator. So it's down here at the bottom. It's the most important, so it's down at the bottom. But yeah, it walks along looking for these vertical bars, and each time it hits a vertical bar, if it hits a vertical bar, then it knows the rule succeeded. But if it fails, then it skips ahead to the next vertical bar, right? Does that make sense? So the block is just stepping through its alternates based on those vertical bars, and it does some other sort of heavy lifting. But again, that's nice to sort of realize is that even blocks can be overridden. So if you have some different idea for blocks, you don't have to rewrite all of Uparse. And in fact, I've mentioned how Rebol 2 has its own combinators that are a little bit different. I think I've pretty much settled on the idea that I like while better than any. And I like the semantics of while better than any. I think that the idea of rules that check for progress, it sort of it makes it weird, right? Because we had while, which didn't, and they had any and some that did check for progress, but while was the counterpart to any that didn't check for progress, and then some didn't have a counterpart. And just like I mentioned, the fact that any really seems like it should mean alternate, right? Because that's what in do, any is like a list of alternates. But we use vertical bars for that in parse. But it seems that if there was an any in parse, it would be the meaning of what you get from vertical bars. And there might be some reason to have a block form of it. I don't know. Or common form. So yeah, we have the old style set and the old style copy. And there's a lot of points on the forum where I talk about what's kind of weird about old style set and copy, being that they would quote arguments. So here you see that the way a combinator, if it doesn't want to do rule interpretation, it can say it just quotes the argument, because you don't want, if it's set X, whatever, you don't want X to be turned into a rule. But I don't use any of these quoted operators in Uparse. And specifically like the seek operator for going to a position. I have a post about why seek doesn't take a variable, it actually takes a rule. So you have to give seek a rule that evaluates to a position. And so you can use a group to do that. And so, yeah, we now have this notion of like things evaluating to so it really is whatever the last value in the block is, and that includes group rules. And this is pretty useful. I really think that people are going to find this is preferable. And if you look at Red, in terms of comparing what you can do with that sort of old style parsing, I think they're going to, they don't seem to have adopted the set word thing, which Gabriele did first. And I was always looking at it like, I don't know, is this a good idea? Because I kind of wondered if it made parse code look too much like regular code, or I don't know what the general fear of using set word in that way
I completely think this helps make it much easier of a transit. Like I think parse in general has been like just a different beast within Rebol, and I think this helps kind of make it a little bit more logically consistent, so it's a little easier.
Yeah. Well, I think the extension is pretty important. I think that having, certainly the synthesizing of values, the inability to build up more complicated values from smaller ones is what drives the desire for features like collect. And Gabriele had also made a like an object. I didn't actually see this before I wrote mine, where I had gather and emit, but he has an object thing for, again, this is all about synthesizing up results.
Who's this?
And that was just very painful. All of your synthesizing actions was about breaking into imperative code and trying to take the little bits, the non-synthesized bits that you had captured, and poke them into variables. So this is a pretty big deal.
So, I mean, have you tried using that on rewriting TLS?
No, not yet. I don't know. I'm sticking with things that don't really care about performance for starters until the bits are converted into natives. But I think the next target would be something like the end capping. But yeah, I'm happy with doing little things. I mean, zip doesn't have to be fast because all it's really doing is sort of parsing the envelope structure in a very limited way. So it was a good test, and it's good to look at these things and to think about how they work together. And I just have to say, it's like these features like you lied, are critical, like in generic quoting. I just don't see how any of this comes together in any meaningful way to be a different medium without it. So, and the multiple returns are really good too. I think that not having multi returns is very limiting. And what I like about how multiple returns are done here is that it is really different. I mean, it's a very RenC specific Rebol universe answer to what multiple returns would be, which breaks out of kind of other concepts while still using the reusable set blocks. And I just rewrote multiple returns to be native code because I wanted to do something with them. Why did I do it? Oh, I wanted a feature that I ended up almost not using, and then I ended up using it after all. But I rewrote it as native code, which is important because Uparse was using it a lot, and it was speaking of things that were extremely slow. Multiple returns were extremely slow because I just prototyped them directly with API code, librebel code, right into the middle of the evaluator, which is pretty cool. But yeah, so
Uparse, you've mentioned that Uparse features would make it into parse code, but you're saying that it will stay user mode though, right? That's the philosophy, right? So
it will always be able to call combinators that you write in user mode.
Okay.
So you can always use a mix.
I just wasn't sure if we were saying parse was going to become user mode and these features would, Uparse features would go into that, or
I'm not really sure about the game plan. Timelines, just in terms of timelines, like there is no timeline. So to me, I looked at this and I'm happy with how it looks, and I think that it's a compelling story, and I really do think that the goal for me is to show, like, if you go like, okay, well, we know we're not rigorous like Haskell, and we know we're not going to be fast like Haskell, but at least we're more expressive, right? And then if you look at it and you go like, no,
come on, we're like the octopus that can, like squeeze through a hole the size of a dime. We're flexible.
Right. So the good news is that by building this and looking at it, I mean, I really do think there's something, a unique story to tell here. It is different. But it's important to notice the parts that are the same. And I've given these examples of, like, you're not going to be a very good filmmaker if you walk into a credulous room of people and go, oh, it's the most original thing that's ever been done, and I can't put it into words. And you just kind of have to get it. But whereas if you can say, we want to make a movie, it's like Jaws but in space, it's like, well, then you can make Alien, and you can bring in the parts that are unique.
I was explaining the film. Have you ever seen I think it's from the late 70s, maybe early 80s, called The Car. And it's just exactly Jaws, but the monster is a car and therefore on land. Anyway.
Yeah. Well, so I think that and another thing that really that has gone well, and I think is really that deserves its own full talk, are those GitHub actions. So RenC action. I really want to see Graham get off of Travis and use this, because it's really easy. I mean, this is all you have to do. You're in your middle of your script. You got a server that you brought up with only a few lines of YAML code, and you write, uses. You give it this, part of a URL and a version number, so release version, and then you just write your script, and it runs. And the neat thing is that this is actually working for anyone. I mean, anyone in the in the whole wide world could put this in a script, get a Rebol interpreter, and it caches it so you can use it multiple times for multiple steps and run code. And so I'm interested in what we can do with dialecting in this, like what happens when you create a little tool that that goes a level above this to do something useful on someone's GitHub repository. And that's and I even added it so that for the web. So the web build, you can actually ask it to run your code in the web build, not on the container. So it actually brings up a headless Firefox and runs it.
Brian, you should update that example to use Uparse in between.
Yeah, well, for the moment, let's limit our problems to the ones we already have. So yeah, here, like this is the testing of the web build. And right now, what does it do? It sets a variable, it watches it, because I wanted to make sure that the watch list was staying working. Then it, or at least, getting to completion. And then asserting that the watch list retrieved the value of the first watch in the list, running the Rebol emulation just so it doesn't go bad. And yeah, I mean, you can, if you have any repository that, like Graham, your script, if you come up with a way that script can run some kind of self-test, and even if that's just like making sure that you can do it and not run it, have some way of doing the script, and then you can see if like it even just loads. But you can do all these things. You can basically automate the web build, and that's pretty neat because this is running a headless Firefox behind the scenes. And
so there's no way to actually interact with your script. So
well,
I use a lot of
there could be. We can certainly work on that concept, because what's actually happening is that it's sending keystrokes for this code to the to a headless browser. So the way that this script is getting in there is by scripting keystrokes into the browser. So we could arguably have it so that you can give it a script and then script the dialogue. But I mean, the question of how it would react, or you presumably want to be reading, sort of controlling it. It's a complicated problem. So it's not out of the question to think about, but I kind of want us to focus on, a few specific things. I mean, for me right now, the main thing that I want to get back to when I get back to it is continuing to think about modules and binding and the sea of declarations, which was coming along, and to really figure out where that's going. Because that's modules, binding, what the nature of variable declaration is, and having a model that's workable. I mean, part of me would say, I would say like, oh hell, forget it. We don't need to do better than JavaScript, or if a model like theirs could be applied to what we're trying to do, I'd say fine, just do it. The main problem is that it does, we're looking to offer a very particular sweet spot for how people are putting code together. I was just looking at Rust and Rust macros, and they really do a good job of when you're doing a macro that's rearranging and rewriting source. You know, it's like if you take a piece of source from what the user wrote and you move it down into generated code, it follows the line and column and file of the original piece of code to report the error pretty well. Like, you know, most languages, as soon as you start doing macros, if there's ever any error, the error is always very much about the code that got generated. It's very removed from what you wrote. You know, you put something on line 10 and then a macro expanded into a file of hundreds of lines. Your error message very rarely points you to that little bit of stuff that you wrote in a precise way. But Rust has done a pretty good job of, if you pull tokens and move them around and in a certain way that's fairly intuitive, it gives you pretty good errors. And, you know, we should be able to do that at least as well as they can. Are we doing it that well? No. But could we? Yeah. So, yeah, just trying to figure out how to tell compelling stories. And I think the Uparse story is pretty compelling when you compare it to parser combinators on languages that don't have the ability to sort of be very lexically free. You know, they're always, every time they call something, they've always got to put parentheses around it. They don't have the different token types. And, you know, they couldn't just put vertical bars between things to signify alternates. They always have to say alternate and then parentheses, and then it calls a thing that has parentheses in it. And they'll never be able to break out of that because that's just how their language works. So Rust actually does have some macro abilities to do better than that. They do have a token stream that they can read across and rewrite. So there's some similarities, but also some limitations that they have that we don't have. So, all right, it's an hour.
Are there any protections? I mean, I tend to write parse rules that tend up to be infinite. You know, so that just keeps on going forever. And is there any way to protect yourself against writing infinite recursive parse rules?
I think the best. I mean, well, I don't know if you saw this, Graham. I'll show you something.
Hey guys, I got to drop. I mean, I was supposed to be somewhere long ago, so
right.
I gotta go.
Thanks.
Thank you.
Hope we can get you committed with your thing and transition you to some Uparse for at least some of it.
I completely agree. Thanks, guys.
Okay. Later.
I'll show you something, Graham. If you didn't see this, because it's kind of cool.
So the other thing I was wondering about, you know, was, you know, I noticed that you did sort of iterative parsing through. I mean, is that sort of style, or can you use recursive parsing, or
iterative parsing?
Yeah. So I think it was. You had the same rule, which you used a cycle on. I mean, can't you use recursion on those things, or is that just style?
That's just style. I mean, recursion eats up stack space, and, you know, I don't know. We're not stackless yet, so that has problems. So yeah. So what was I going to say? I was going to say feature that you. Oh yeah. So Uparse has some refinements on being able to get the furthest things, like the furthest point. So I can say Uparse A B B sum A C C C, something like that, and then I'll use the non-multi-return. Yeah, I haven't tested this lately. Remainder, get remainder. Yeah, I haven't tested this. I need to add this to the tests. But one thing that it was able to do and should be able to do once I fix it is it can tell you how far it got in the parse. Like what's the furthest point it ever reached. And that's pretty useful to know.
Yeah, yeah, absolutely.
So...
And what about debugging? What about debugging parse rules? I mean, can you trace along the parse or?
Well, that's one of the things that stylizing these into combinators that are functions that have frames is that whatever the debugging answer is for code in general, it should be able to hopefully work for this too, because we'll be able, you know, the ways, I mean, you can already kind of, yeah, it'd be hard to show you, but these are functions, right?
Yeah.
They are frames. So there is a stack and you will be able to see where you are in the stack and whatever runs single stepping and stepping in and stepping out, stepping over and all that should be adaptable to it. But of course, that's a really big should, you know, I mean, these things don't fall out of the sky. They have to be written. So who knows how long it will take. I don't know if I have another 10 years for this, but maybe I do. I think it is interesting. The more I look at the way other people are doing programming and where code is going, it is just pushing further and further away from freedom. And so it's kind of like this message of the free form, you know, sort of clay modeling, and it's just going very much out of style to the point that it might indeed become retro. And I've mentioned the areas of sort of gaming, you know, treating programming as a game where these kinds of things might just be fun. But certainly super small, flexible systems, the idea of being able to code on your phone, being able to have an environment that still works in some meaningful way, even though it's very, very small. I don't know. Could go somewhere. Beats me. But Uparse, to me, Uparse is so obviously, you know, changes that are needed to make this, you know, parse is supposed to be one of the big stories, right? Like, hey, look at this. And when it's not good, and the competition are getting better, then it needs to get better. And I think that Uparse does that, you know, brings it up to be competitive and interesting in its own little way, you know.
Well, I agree that, you know, parse has always had those frustrating bits about, you know, you copy, then you had to, you know, skip the same thing that you already copied just to get through that tag or whatever it was. That was annoying. So what's the best tutorial on using GitHub Actions? Is that
just read the I mean,
read the source. Read the source. Yes.
read what I write. Like read the README in GitHub workflows. You know, read the source for how we build. I mean, if you want to know how to use a Rebol GitHub action, the best places to look are like the, you know, HTTPD. You know, here we have the workflows, stress testing the HTTPD server. That's all it takes to do it. And here we're doing it on Mac, Windows, Ubuntu. So you can see the, here's all those platforms, debug and release, running the HTTPD stress test, right? So, here it is on Windows latest, and it shows you the steps,
Okay,
stress
all right,
test,
okay.
transmitting ever increasing data. So it takes this, what it does is you tell the server to start out by sending the string hi code point cat, and the first time it just sends it once, and the second time it sends it twice. Then it doubles it. So it's going through doubling it each time, to see if the client checks to make sure that it reads those exact bytes. And then there's stress test where it actually hangs up the client at random moments, and to see if the server is robust with respect to the client hanging up at random times, right? So that's pretty cool to see that running on all those, right? And all it takes to get these running is that code in the
What's that latest and false? What's that false and true thing that you got there?
debug, not debug.
Hey? Oh, okay.
Debug and release. So yeah, you have a matrix, and these are just basically environment variables, not quite environment variables, because they're matrix. They're GitHub Actions matrix variables that you can put into environment variables if you want, but you can use them in the script where you would use environment variables, but they are not actually environment variables. And yeah, so this is actually not using, this uses the download and cache the interpreter. So this, when you use the action, the renc action, you can either give it script code that it just runs right here, or if you just say this, then it puts the executable R3 in your path. So, but either way, you can mix and match, and it will only download once. But pretty easy. This is telling it to download. You get the debugger release interpreter based on what you set in that matrix, what setting in the matrix it's running. And that's all it is. So, you have to check out, you have to run an action to check out your repository. On Windows, you have to disable character and line feeds when you get clone. And that's about it. You have to say what operating system it's on. And so here we put the OS in the matrix. And then when we get to runs on, of which we use the matrix variable. So that's why we get 6 different builds with 3 different OSs, 2 different variations. But yeah, what was I going to say?
Are we still getting binaries at all?
Say what?
Are we still getting binaries at all?
Yeah, I mean, those are, same locations, same things.
Oh, well, it sounds very encouraging. If I only had a brain. If you only had a brain.
Well, say renc.
Or maybe if I only had a heart. I think maybe it's only a heart.
So if you look at, sort of some of the examples, let's see if there's anything novel. It's between, which is cool. Collect. Yeah, and the gather. I really like this idea that I proposed about importing things that you gather, but
Are you saying that you could parse a stream and put all the collected variables into an object?
Like that.
And return an
So
object?
gather is like collect, except instead of collecting it, it lets you put the, with this emit instruction, you can set variables. Gabriele did something like this, which I didn't notice until after I'd done mine, but in his, he called it object. And so it was like object, and you didn't need the emit. You just do like I integer t text. And I liked the idea that you would actually have a special instruction done in this kind of style. Just kind of appeals to me more for some reason. But there might be, the point is we can experiment with all kinds of designs. Like before, if you asked me, hey, could you do this? It'd be like, I don't know. Like it was always very hard and the code was convoluted. And it really didn't have, now things that just wouldn't work before because, of confusion. You could say like collect some keep a, or try. Being able to return things easily, like I added this return back in, but I have questions about it, so we have to talk about it. But yeah, you can write some keep a, or you can write some keep a. You can write some keep a. Before, if you've, some things would be supported sometimes and some others wouldn't,
Yeah.
It was just very irregular. The whole way that everything worked in parse was very ad hoc. It was trying to be optimized, and it's worth doing some optimizations, and we're going to certainly need to, but they're just error. You could put in all kinds of invalid input and it wouldn't know that it was skipping over something, and you just get random, errors out of it. So
I'm just
this
wondering,
is much more, has much more of a regular architecture to it.
I'm just wondering whether it's useful if you're parsing a binary, if you have a hex native data type. So instead of saying integer, you can use hex, so you can collect hexadecimal values.
What do you?
Well, if you're passing a binary stream, you're looking at hex values, aren't you?
Yeah. So, but you mean because it's shorter than that?
Yeah. You could say, well, I want to collect the next hex value and store it. So it's a data type rather than a couple of binary characters which you don't really know.
Oh, well, that's what dbin. I was proposing dbin for that because dbin, big endian plus 2, little endian, right? So this gives you all those, all the, the hexadecimal conversion matrix, and you don't have to tell it how long it is if it's, but you do need to tell it if you're encoding it, right? So nbin and dbin are very good for this. Is this what you're talking about?
I think I was just looking at a instead of having as well as a decimal data type, having a hex data type.
Oh, Oh, you're saying that's if you're parsing a string.
Yeah, parsing a string. Yeah.
Oh, yeah. Oh, yeah. Sure. I mean, yes. The one thing that's coming out of this is that you can say parse, 1, 2, 3, 4, 5, 6. Uparse. So
yeah, so instead of integer, have hex there.
yeah.
No.
I mean, I feel like
too much.
It's good to have a library of those kinds of things. I don't know. As you can see, we're certainly on. This is on a path for doing any kind of synthesis that you want, and making it easier to make combinators, and like I showed you, you don't even have to write a combinator. What's the thing for converting a hex string? Hex. What is it? How do you convert a what's the thing for? No, that's the wrong one. Dbase. I mean, I don't remember what any of these things work. Is that right? Well, I'm not really sure.
I can't remember. It's just that when you're looking at file data types and this sort of thing, you have to parse these binary strings to see what sort of file type it is, and like PDFs have this sort of sequence, and PNGs and JPEGs all have a header sequence, and
well, you come up with some concrete examples. As you see, it's not it's not really rocket science to write these new ones, and you can now, because of the way that, like I say, you don't even have to write a combinator.
Okay, I'm just thinking back to when I wrote that server thing. What was it now for? Can't remember what it was. Can't remember what it was. That Philips Hue bridge server, which was looking at all those streams being passed. I mean, those messages that being passed along a network, and try and pick up messages to turn light bulbs on and off, that sort of thing. Can't remember what it was now.
Yeah. Well, a lot of possibilities here. We got the real question. I raised this question that I think is an important one, which is about how return subverts the the completion of the checking. So if I say uparse AAA BBB sum A, return sum A that BBB, you don't get complete matching. Like, it doesn't fail. It doesn't tell you that the return. So I'm wondering if return should by default only work if you are at.
Yeah. Hello. Yeah. Yeah. Oh, take it away. I'll take it away. Yeah, yeah. Gotta have lunch and then come round to the Austin Street, pick it up. All right. Okay, bye. Sorry, was it? Sorry. Yep.
Well, I'm just wondering if like return should require that you be at the end. Like return should only match if you're at the end, because I feel uncomfortable about leaving these residual parse results around. You know what I mean? Like this matched the sum A, but the B's weren't matched. But so
I mean, normally
I do think
skip to end. Don't we normally sort of try and get to the end of these things.
yeah, maybe it should be explicit in your rule. Like, maybe you should have to say turn sum A, you know, elide to end, or you know, or maybe it should be an option on return. You know, return incomplete.
Break and return break.
Well, hard to say. I mean, I guess maybe I just feel, but I want it to be really easy to be able to do something like, you know, I want things like that to be easy, and maybe it just really does have to be at the end. I just wonder how people are going to understand that.
Well, that is at the end, isn't it?
I was also thinking, you know, uparse return a select sum keep A, you know, where you tell it at the top level to return the result of the rule. And then I was even wondering if that should be the default return value, but that doesn't really make much sense, because what if you say, for instance, sum A opt B, then you're even getting null back, right? Like, because null is the result of the last rule. It succeeded, but it was a null. And so I kind of do feel like by default, the input is a better answer than that. But I don't like the idea of of you accidentally missing out on input that you didn't process. So maybe it isn't, you know, it seems to me that maybe every way you would phrase maybe return is the wrong keyword. I don't know. Like well, there's a lot of little subtle questions like this, and it's hard to there's a lifetime. There really is just a lifetime of stuff.
Yeah. Okay. So just going back to what I was thinking about having a private store. So we don't actually have anything like Azure or Amazon or whatever at the moment. So maybe I will just use the existing mechanism that we've already got. And just use the, you know, how it's built into the binary at the moment where our libraries are kept.
Yeah.
Yeah, maybe do something like that. In the meantime, until we get S3 or Azure or whatever.
Well, for you, I mean, it's we're waiting forever for Ed to finish his thing, but you know what I just want everyone to do is to work on something that is interesting to you, and as you see, things can now be kept running. I mean, we're not in a state where things aren't running. I mean, the Android build is actually being tested in a virtual phone that's in the cloud. So
Do we have the build available for that? Is that also on S3?
It doesn't build. It doesn't save the APK anywhere.
Oh.
It could, but there is no upload location or scheme for the APK files.
Pity.
So if you want to, I mean, I encourage you, if you're passionate about any of those things, to just, I mean, the GitHub Actions stuff is way clearer than Travis. I mean, everything is much more readable. Like, you want to see how it uploads the
yeah. So Travis, you had to have private keys, and you had to have well, your private key was stored on Travis itself, wasn't it?
Well, you still have to do that. I mean, that's
yeah, but I mean, but your private key, where is your private key now stored?
same difference. You know, it's part of the
so it's set up
GitHub
on
settings.
GitHub has their own private key, which it creates for you.
Yeah, we did it like a long time ago for the web build, right? Like it's in here somewhere. It's yeah, configure.
Yeah, that's
secrets AWS access key. So it uses a GitHub action to configure it.
Okay.
And then it uploads it. Here it is doing the uploads.
It's using AWS, so that gets installed. Okay. Which
AWS S3 CP copy file local to remote.
Yeah, so AWS is a Python binary, I think.
So all the stuff about getting the right version of AWS and all that's all taken care of for you by these actions.
Oh, cool.
We had to like get the right version of pip and all that, but we also ran on some older Linux containers. But yeah, same difference. You know, it builds it and then it runs it from the server by the git commit, and once it is done, it greenlights it by uploading the hash, but it has to get to here first. So yeah, I mean, it's all pretty simple. And if you you know, get involved, as you can see, it's all very clear. You know, I'm one of the clearest people out there.
Yes, you know, it's just managing one's time. That's all.
Yeah. All right. Well, hopefully you feel good about Uparse there.
Well, I'm very excited about how Uparse is looking, for sure. I mean, I didn't really understand, you know, I didn't really have the time to read the forum to actually grok what was happening. But now that it's been explained, it's yeah, much more interesting when we see it explained.
Mm-hmm. Well, yeah, it's the notion of having the blocks actually fall out and evaluate to their last result, and having these weird properties like you know, you might think it's kind of strange for some A just result in A, but it's cheap, right? It already has A in its hand. So it's not generating any new series, and it's not useless, right? This, by returning the last thing that it got, you know which branch you took, right? So that's helpful. But you could always evaluate to something else. Like groups actually evaluate. See? So before, remember, we were all kind of wondering, should groups be invisible or should groups like should groups be should you be able to keep the product of a group, right? Like like, should you be able to do that? Should you be able to, because the way that we phrased it, or the way that I was confused about it, was I was like, oh no, the parse rule is actually seeing the result of a group, and that kind of undermines your confidence that groups aren't producing something. So I was worried about what happens if you say uparse a first a, something like that. Like, should that work? I was concerned about the results of groups being seen by the parse. And the reason I was concerned was because there wasn't this distinct concept of a parse rule returning a synthesized value that was distinct from the, sort of the stream of instructions, So, but now that we have that distinction, it's okay. I mean, this isn't an argument to anything, so it just gets, and it doesn't get thrown away. So groups are always evaluated to. This is really handy. Like I posted about, I put you on a pull request back when it was on Rebel server, or I think it was Rebel server. Yeah. So files changed. So this is just an example of changing some code from Giulio doing some command line processing. And what does he do? He's using iterate here. He's getting system options args. He's like, okay, we're going to go step by step through this. And if we see the first element is -a, then we're going to do A is the next A, and then we're going to, we're going to interpret this command line parameter as either the word true, then true, or false, or we convert it to a file. So he's doing command line processing on this case statement because parse, would be inconvenient. But look over here, right? We're parsing the args, use a while instead of some, or any. So then we process the -a, and then we can say access dir is the result of whatever this rule is. So if we reach the end, then it's just true. If it's the word true, it's true. If it's false, false. Otherwise, we get the next item as a directory, but the overall block evaluates to that being to file. See? The block rule evaluates to whatever clause it makes. And that's pretty clean. So really, this makes parse more, more useful across the board.
Well, it's certainly clearer. It's certainly clearer than the left version there.
Yeah. I'm still kind of working on this question of some other syntaxes across. We can talk about that at some point, but
that won't. But uparse won't work without it actually being in the binary, though.
It's in the binary.
Hey, but you had do uparse. I just saw that on the web.
That's because the web build doesn't include it as a binary.
Oh, okay.
The reason why doesn't it? The reason it doesn't include it is because it's the way that it gets included in the main binaries right now is the same way that things like TLS and whatever it's packaged in as an additional sort of auxiliary script, and that packaging is not enabled for the web build.
Okay, all right.
The web build is its own thing, package wise. So there's no technical reason why it can't run. Obviously, that's why do uparse, and we could, in fact, I should make it just do uparse when it boots up. But one of the main reasons is I don't want people to get used to writing uparse because it's just going to be parse. So, yeah.
And is that going to be subject to a lot of flux, or I mean, is that something that's stable enough to use now, or?
Well, you know something. If I'm the only person looking at it, and we don't have a lot of scenarios to inform it, and people aren't working on it, and people aren't commenting on it, then yes, the amount of flux it will go through will likely be a lot over time.
So if Ed starts writing his thing in uparse.
Well, if it can survive Ed's thing, and if it can survive, so far it's kind of made it through, some initial testing and zip just for the basics.
Yeah.
But I think that, I think the basics are probably, you got to realize that some of these things are big decisions, right? The idea that a block rule evaluates to a result, and, that's a big change from the old way. So, and I had to come to that conclusion that it should do that. I mean, this is an invention. It's not how anything else works. And I guess time will tell if Red decides it's a good enough idea to copy it. Or if because I came up with it, they're going to decide to avoid it forever.
Well, that means you just have to generate enough ideas they got nowhere to go.
Yeah. I that's basically been my plan. If they try to avoid everything that I've created, then they're really just going to be in the
Rebol
design space of only bad ideas. So I guess that's fine. Yeah, it's a big change to have this policy. And I'm trying to, every little bit that comes along, like how the ats work, that's changed back to what I initially thought I was going to do with it. And it's working pretty well. So yeah, I look forward to you, getting in there and working on it and helping design it. And, this is a case where it has been true in general in Run C that, features can be done. The code base is not like locked in stone. It's able to be changed. And so this is even more ability to be changed and designed in interesting ways. All right.
Okay, we're going to go. You're going to have lunch, or you're going to go to...
All right. Have a good day.
Okay, well, thanks very much for that.
Sure.
Okay, catch you later.
Later.
Bye.
Bye.